Hi everyone, I am Priya Jose, Assistant Professor, Department of Basic Science and Humanities, Jyoti Engineering College, Chirudurti. Today I will discuss about fiber optic sensors. This is a topic from Module 5 of Engineering Physics B for S1 or S2 B.Tech program. Fiber optic sensors. It's a sensor that uses optical fiber as a sensing element. They are used for sensing physical quantities like current, magnetic field, acceleration, pressure, etc. It consists of three parts. First one, a light source. Second part, a fiber sensor element. This fiber sensor element consists of an optical fiber through which this light is allowed to pass, and the measured signal. The quantity to be measured is applied here. Then this measured signal changes some of the property of the light, for example, intensity or wavelength, through the optical fiber, and that change is measured with the help of a light detector. These three are the basic components of a fiber optic sensor. Different types of fiber optic sensors. Intensity modulated sensor. If the intensity of light through the guided fiber is changed, then that fiber is called intensity modulated sensor. If the phase of the light through this fiber is modified by the measured signal, then that fiber is phase modulated sensor. If the polarization of the light through the fiber is modified by the measured signal, then that is polarization modulated sensor. Like that. Another classification, wavelength modulated sensor. First we will look at the intensity modulated sensor. For a sensor, there are three parts. First one, the light source. And second, the fiber sensor element, this part. And the third, a photodetector. In intensity modulated sensor, the intensity of the guided light through the sensor fiber is modified. So the name intensity modulated sensor. Here, this is a light source which emits coherent monochromatic light. The beam splitter divides the light beam exactly at right angles to each other. One part of the light from the beam splitter is allowed to pass through the reference fiber and to the photodetector. The other part passes through a fiber without jacket, and this fiber is placed between two metal blocks. This is the upper block and this is the lower block, and the fiber is placed between these two metal blocks, and this is a fiber without protective jackets, which contains only core and cladding. Then working. When a force is applied on the top block, it presses the fiber inside this block, which introduces micro bend losses. If you apply a force on the top metal block, then it presses this fiber. This is a fiber without protective jacket. Then it introduces micro bend losses in it. Because of this loss, intensity of light is changed, and this change in intensity is analyzed as compared to the light from the reference fiber. Next type of sensor is phase modulated sensor. In phase modulated sensor, the phase of the guided light through the fiber is modified. Here also three parts. First one, light source. Second, the fiber sensor element, this part. And the third, photodetector. Here the light source emits monochromatic light and which is incident on the device beam splitter. The beam splitter divides the light beam at right angles to each other. One part of this beam is allowed to pass through the reference fiber. The other part from the beam splitter is allowed to pass through the sensor fiber element. Working. Here the sensor fiber element is heated. This component is heated. Then the fiber elongates and thereby increases its length. Then the length of the light path also increases. This increase changes the phase of the light through the fiber. This change in phase of light is analyzed as compared to the reference signal. Then advantages of optical fiber sensors. They can be used in explosive environment, immune to electromagnetic and electrostatic interference, ideal for microwave environment, resistant to high temperatures and chemically reactive environment, ideal for harsh environment. They are small in size. They can monitor a wide range of physical and chemical parameters. They have high sensitivity, high range and high resolution. They monitor extended structures like pipelines, dams. Let us conclude this topic with the applications of fiber optic sensors. These sensors are used as fluid level indicators. The temperature sensors are used to measure the temperature. They are used to measure various physical quantities such as velocity, current, magnetic fields, acceleration, pressure, etc. The pressure sensors are used to measure the pressure. Thank you.